I'm going to start with a demonstration. This is a camera flash, but we took out the little flash tube and replaced it with this big tube. Now right now, there's 300 volts between the sides of the tube. But the 300 volts is not enough to make anything happen. There's no light. But if I could ionize the gas inside that tube, if I could tear electrons off the atoms, then the charges would start to move inside the tube. There'd be a discharge, and we'd have a flash of light. And I can tear electrons off of atoms by doing this. I'm going to take this tube, I'm going to charge it up, just like we did before. I bring it near the light bulb. Watch this. Oh yeah. And then I have a discharge. So there's something in space around this rod that tears the electrons off of the atoms and causes that tube to discharge. And what it is around this rod is its electric field. I charge it up, and it's able to make something happen at a distance. And so we have this concept of the electric field. When I charge this rod up, there's an electric field around it. And objects that are near it can sense that field, okay? Now let's take a look at that, and we're going to come back to an experiment that we started with. So remember, we charged up the cups by rubbing them on the fleece. And when we do that, the cup is positively charged. I'll put it here. When I charge the rod up, the rod is positively charged. Now, when I bring the rod next to the cups are pushed away. So think about this. This rod is positively charged, and in the space around it, we're going to use this concept of the electric field. There's something around the rod, so that if charges are near it, they're aware of its presence. We'll start by representing the electric field as a series of vectors. And the vectors show the direction and the magnitude of a force that's experienced by a positive charge. We're going to define the direction and the magnitude of the electric field as the direction and the magnitude of the force that's felt by a positive test charge. So, for this rod, it's positively charged. I bring it next to these cups. The cups experience a force that's away from the rod, so the electric field points this way. On the other side of the rod, the electric field points this way as well. And so the electric field points away from this rod in every direction. Now in the book, you're going to see electric field diagrams for different charge configurations.